The length of a rectangle is one more than a number. The width is 5 less than that same number. If the area is 27, find the unknown number. Right, so we've got this word problem. The important information is here. Length is one more than some number. And the width is going to be 5 less than that same number. And we know that the area is 27. So let's put all that together, find a quadratic equation, and solve it. So first step, we're going to choose a variable for the unknown. So our unknown in this problem is going to be this unknown number here, this mysterious number we're comparing the length and width to. So x will be our variable name, although you could choose any variable name you want, y, a, anything, as long as you use it consistently. All right, second step, express the length and width in terms of the variable. All right, so the first sentence tells us the length is one more than this number. So L is x plus 1. And the second sentence tells us the width is 5 less than that number. Less than is our code word for subtract. So x minus 5. 5 units less than our number. Step 3, we want to write our quadratic equation. So we're going to use the area here. Right? Area is L times W. L is x plus 1. W is x minus 5. And the area is 27 square units. 27 equals x plus 1 times x minus 5. This is our quadratic equation. If you FOIL the right-hand side out, you'll see your x squared term in there. So let's actually do that and put this in standard form. So if you FOIL this, you're going to get x squared minus 4x minus 5 equals 27. And if we put everything on the same side, x squared minus 4x, subtract 27, we get negative 32. All right, and then step 4, we're going to solve this equation. So you can do this using any method you want. You could graph it in Desmos and look for the x-intercept. You could factor it. There are a few different options here. So pause it, think about that, see if you can find the solutions here. All right, so hopefully you solve this on your own. You should have found something like a factorization of x minus 8 times x plus 4, which would mean by the zero product property, x equals 8 or x equals minus 4. Remember, when we solve for 0, the signs get switched. Negative 8 becomes positive 8, and positive 4 becomes a negative 4. Right, so our unknown number, it could be 8, it could be negative 4. We got to figure out which one makes sense. So that's step 5. So if x equals 8, then the length would be 8 plus 1. That's our x plus 1 formula here. X plus 1 equals 9, and the width would be 8 minus 5. So that would be 3. So 9 and 3 is length and width. That makes sense. They're both positive values. And if you multiply it, 9 times 3 is 27. So that would fit. If x equals negative 4, then what happens? So the length would be negative 3. Negative 4 plus 1 is negative 3, and the width would be negative 4 minus 5, which would be negative 9. Negative 3 and negative 9. That doesn't really make sense, because when we're talking about lengths and widths, we're looking for positive values. So the solution is the only value of x that gives us reasonable lengths and widths, x equals 8.